Good morning, everyone. Thank you so much for being here with us, the ESIP Schema.org cluster, for this tutorial, which we haven't run in a very long time. But it comes at a pretty important time for our cluster, as we just recently published a new version of the Schema.org guidelines. And so we thought we'd take this opportunity here at the summer to walk the community through what we've been up to, and to just sort of revisit the fact that maybe this is new to some folks. So we're going to get down and dirty into some data and into some like Schema.org markup. We'll probably save a lot of the philosophical stuff probably towards the end, or if you've got a question, happy to answer it. But we really want to just sort of walk everyone through, first of all, just how easy this is to do. And then just show you some of the concepts, the tips and techniques, hopefully we're not tripping you up, of how to use the language JSONLD in Schema.org specifically. So yeah, feel free to bang on the computer. So I guess the first thing I need to do is invite you to add yourself to the attendee list in the Google Doc. And so if you're there in Kiko chat, it's just at the top of this Google document, or if you've happened to click into the tutorial already, there's a link to the session notes where you can add yourself as one of the attendees. Today's session, like I said, is a tutorial, but it's going to be very informal. So if you have questions in the room, just feel free to raise your hand. We've got a microphone here for you. If you're online, we have Sarah and Doug watching the Zoom chats. Sarah's sitting here in the front here for you all in the room. So please feel free to type your questions there as well, or interrupt me. I tend to speak fast, so I'll try to slow it down, and I'll try to be cognizant of what's happening here in the room, but Doug and Sarah have online, so we really want to make this useful and important to everyone here, so that you can understand the concepts and the new techniques that we've derived in the new guidelines. But please feel free to add notes to the Google Docs, but if you're working in code, maybe do that in your own space, maybe on GitHub or a Gist or on your local laptops, and maybe not code snippets in the Google Doc, but use your discretion. Yeah, this is very informal. Okay, anything else before we get started? I just want to highlight a couple of the goals. Actually, I should do that here. So the goals for today's session, and no offense if you want to just move on to something else, we won't be offended. I don't know if they put tomatoes in the back of the room, but feel free to heckle and throw them up here or walk out. Either one of those are acceptable. But the goals for today are really to help everyone understand how to build a Schema.org record using JSONLD. To learn some of the tips and techniques of JSONLD, because it can be a little bit complicated looking at the specification for that language. So we want to help you expedite that process of learning some of those tips and techniques, and then ultimately introduce you to the latest updates at scienceonschema.org. And then a super awesome goal would be, and I don't have that on here, is if everyone for their data sets might be contributing and publishing schema.org on web pages. So, all right, with that, let's jump into the tutorial here. If you don't have the link, we've made a bit.ly. It's bit.ly/SOSO-tutorial. It might be a SOSO tutorial, but SOSO really stands for Science on Schema.org. Jump on in, it's in GitHub, and feel free to follow along, jump ahead if something looks like it's too basic for you. We're really here to serve you all in the room and online. So again, thank you for being here. Okay, just a couple things for this tutorial. So for source metadata, you might have a dataset landing page at your repository or wherever that you want to work on, and that's totally cool, and that'll work for this tutorial. But for those who don't, or who just want to follow along, we have an example metadata record. It's in sort of like a quasi YAML format at this link, so feel free to follow along there. That's what the tutorial is built on. And so each section of the tutorial has a specific lesson or lessons about JSONLD or the schema.org vocabulary. And what we'll be doing is at the end of every section, we'll be building a schema.org JSONLD record together. And so it'll comprehensively build until we get to the last section where we'll have a fully complete schema.org record specific to this metadata record in the examples folder. And so if you're working on your own and you have different metadata, maybe it won't be the same record, but completeness is not, following and hitting every single one of these sections. Completeness is really defined by your own metadata record. So please don't feel like you're missing anything. I'm sure your metadata is all great here at ESIP. And so yeah, just follow the tutorial as best you can. And then finally, if you have any questions or suggestions about the tutorial, if anything's funky or you think something's wrong, we'd love for you to just comment on this GitHub issue 226 if you're willing to do that. So I just want to give a couple links before we get started here and rip into the agenda. The first off is the Google Doc that you already have. There's a link to the Schedule page. And then there's two tools that might be helpful throughout the tutorial. And the first one is Google's Rich Results tool. And so in there, you can paste either a URL to a page that has schema.org on it, or a snippet of schema.org itself. And so as we're working through the tutorial, you can cut and paste that code at the very bottom of each page right into the Google Results tool, and it'll give you feedback as to how well we're doing. And then finally, if you're on Chrome, if you're using the Chrome browser, there's this really cool schema builder extension that lets you navigate to a page and start to build the schema.org on your own. Or if there's schema.org already on that page, it'll show you what that record looks like and let you edit it in there. So for those of you who are at repositories, this tool is a great way to sort of like get a kickstart right into building schema.org. So I would encourage you to check that out. And thanks to Doug Fills for finding that tool. All right. So there's a bunch of sessions that have happened at ESIP and online that introduce schema.org. Just a really quick intro is that this is markup that you embed on web pages to describe the contents of that web page to harvesters like search engines, Google, Yahoo, Bing, or other metadata harvesters like DataOne, Ocean Info Hub might be another. And so it's just a way to provide structured information about the contents of a web page. There's a ton of resources. Recently, we just presented to the soil cluster, and so there's a YouTube link that you can go to watch that. It's about a half hour long, and the slides for that are there as well. And then finally, I mentioned that the group at ESIP just published a new version of the guidelines that came out in May. You can click to view the release notes, but a lot of that is built right into the tutorial. And then finally, that version of the guidelines is up for ESIP assembly endorsement, and so there should be more coming out to the community shortly. So without further ado, let's jump on in. And actually, I do want to say, maybe this is an old page, just a quick shout out to some of the folks in the schema.org group. Special thanks to Matt Jones, Steve Richard, Nick Jarbo, who's here with us at the table, Dave Vieglis, Doug Fills online, Ruth Dewar, Chantel Very, and Melinda Minch. These folks really just sort of were in the trenches twice a month working on these guidelines to make something like today possible. So a special thanks to those. All right, well, let's get started. And please, again, this is super informal. Work on your computers and interrupt me as you will. All right, so starting out with the schema.org record, there's two main concepts in JSONLD that are critical to making this work. And that's, first of all, defining what's called an at context and an at type. First of all, can you all see this in the back? Does it need to be bigger on the screen? I'm getting so, maybe a little bit bigger. How's that? Keep going? Is that better? Okay, online, are we tracking? Is everybody good on Zoom? Maybe a thumbs up from somebody. Okay, great. All right, thanks. Okay, so not to belabor this point, this is all like philosophical stuff and we don't need to delve into it too far, but essentially all you need to do to get started is this code snippet at the bottom here. So defining an at context with the URL to schema.org and an at type to the type of object that you're trying to describe. And so for this tutorial, we're going to be describing data sets. And so I'll mention that the at type is a data set. So just one little thing about the context and what that does. The context tells whoever's harvesting this record that, hey, everything in this document, it should be contextualized as properties of schema.org. And so if we were to fully type out that at type, you would just append the context URL there in front of dataset. And so that's all that really means. And I've given a link to the dataset if you wanted to see that. In fact, I'll just click it now. What the heck? We're live, right? So if you happen to notice the URL, it's schema.org/dataset. And I know that's really small, so let's make this super big. And so this is a web representation of a schema.org dataset. And essentially all it's doing is it's describing all the fields and properties that you can use to describe that data set on a particular web page. And so the schema.org cluster at ESIP was formed because this documentation is a little bit hard to wrap your head around, even for us, and not to make judgment on anyone's capabilities, but we thought, hey, just to make it easier for us, let's put together some guidelines and documentation so that everyone can do this in a much more efficient and sort of consistent way across our community. Okay, so jumping back to the tutorial, there's more information here at what the context and the type are if you want to dive into that. But let's move on to just sort of building out our very simple data set record. And I should have some, okay, at the bottom of every page, there's a resources section. I want to show you the sample metadata that we'll be working off of to build this record. So let me click that. And did I click it? Did it go somewhere? I can't see my browser here. There we go. All right. Let's see. So in this sample metadata record, I've just really simplified it. Like, here's the title for this data set that we're going to describe in the tutorial, the URL, an abstract, some dates, a DOI, keywords, some information about who the authors are, a license, the repository that published it, some funding information, spatial and temporal metadata, some instrumentation, some description of the files, the metadata files, and then finishing off with some parameters, okay? And so this is great if you have all this information, but totally not necessary, and we'll find that out by using the Google Rich Results tool, that not all this information is needed to have a compliant schema.org data set record, but we're just doing this for comprehensivity of the tutorial. So let me just jump back in to section one. So if you're following along and building your own schema.org record, you just want to use this as the starting point, and we'll move on to basic fields. So first off, are we tracking any questions at this stage in the room? I get some no's. Anything online? We're good? All right. Okay. So some just basic fields, common properties of the data set. And if you're looking at that example record that we put together, really I'm talking about source lines 1 through 4, so that title, URL, the abstract, and the version. And so we're just going to update our record to include these fields into our record. And one thing to note is that abstract is named description, and I did that on purpose. So, you know, in our metadata records, we're going to have certain fields or certain names for specific fields. And the point of doing this is to map our own science metadata into the schema.org vocabulary, okay? And so if you remember about the context and the type data set, there are certain fields on that page that describe what a data set is. Name, description, URL, version, and is accessible for free are all properties of what we can talk about for a schema.org data set record. And so you can go to that schema.org page or go to our guidelines to see more fields, but this is just providing you an example of what to do to start out. So any questions here on some of the basic fields, or we can move on? All right, so we're gonna add in some date information, and this is from that source metadata lines 5 through 7. And so I'm just gonna tack on date created, date modified, and date published. And let's just to hit this point home, is that on the schema.org dataset page, you're gonna find all these properties that you can define for a data set. And so let's just scroll down to those date ones. So here we go. Here's date created, here's date modified, and date published. And so the schema.org cluster group has sort of gone through all this documentation, pulled out the fields that we find are most relevant for consistent metadata across the geosciences, and have provided that in the guidelines for you so that you don't have to make guesses or fumble through the schema.org documentation on your own. All right, and let's see, where am I here? Oops, maybe somehow I went back. So we've added a couple fields. We've added some date fields, and I think we're ready to move on to keywords. Does anyone need a little bit more time or have a question about dates? Yeah, go for it. I'll give you the mic here. No.
So knowing very, very little about schema.org, why are there at signs in front of the content when caption not included?
Oh, that's a great question. Okay, so in the JSONLD spec, there's certain fields that are special, if you will. So it needs to know specifically when you want to specify like a context and when you want to specify a type. Like, so certainly like a bunch of things that you'd want to describe have a field called type. Like, I don't know, there might be a car and you might say, oh, it's type SUV. Well, the JSONLD spec needs to know, like, okay, do you mean SUV is like a property of this thing, or are you trying to tell me that you're trying to describe an SUV? So maybe that's not the best example, but if on that first section, if you want to find out more about that @ sign and why it's there, if you go to that, like specifying the context and the type, it'll describe it for you. But that was a great question. Thank you for asking that. Yeah, go ahead.
If your data set doesn't have one of these, like version number, do you leave the entire attribute off, or do you leave version number blank or null?
That's great question. So you just don't have to specify the property at all. So just omit that particular one. And so yeah, for example, let's say you have no idea if the data set is accessible for free, and you don't want to say that yes it is or no it isn't. You just leave that property out for right now. And so this is a good, thank you for asking that question, because that spurs us to sort of take this little code snippet, and I will copy it, and I'm going to jump over to the Google Rich Results tool. And so if you go there and click code, and you can find this URL at the bottom of every section page. So I'm going to paste in what we have so far, and let's see what the tool does for us. So I'm going to say test code. Usually it doesn't take a minute or two. All right. So what it's done is it's pasted my code on the left and given me my results on the right. And so what it's saying is that it's detected a data set, so that's good. That means like it understood what I meant by that @ type. And it's saying it found one data set and there's some warnings. So I can click this and figure out what warnings were. So it's saying we have 2 warnings, and it's saying, oh, okay, they're not errors, these are warnings, and this is specific to Google's interpretation of schema.org. So what it's saying is that the record's good, but it's saying that I'm missing these optional fields that Google thinks is important. And so for one, it's saying I should add a license field, and we'll do that in a later section. But it's also saying I should specify the creators of this data set, which is also in a later section. And so as we build up that fully comprehensive schema.org markup at the bottom of each section, we'll start to see these, we might even see new errors show up or other warnings, but for right now, this is where we are at with our record. And Google's just simply telling us, hey, it's valid and it'd work and we'd harvest it and we could use it, but it'd be great if you added this license and creator field. So we'll do that in the upcoming sections. Okay, yes.
That plays off of my question. So it has optional, what are the required fields or the most beneficial fields to include if you're not going to have all of these completed?
Yeah, that's a great question. So Google has their recommendation on what they think is required to harvest. And so our group has looked at that and vetted some of those and said, yes, so obviously that makes sense. And it's really basic, like name. I think for another one, it's description. And they might give you an optional warning like, hey, a description should have more than 50 characters or something like that. But it's pretty basic. And I can get you, actually, if Doug's online, Doug, do you mind digging up the Google recommendation for data?
I just put it in the chat.
Okay, great. So if someone can maybe just put that that chat link somewhere, maybe in the Google Doc, that'd be great. Thank you for asking that. All right. So let's move on to keywords. All right. All right, so now we're going to start to learn some of the JSONLD concepts that'll help you down the road. And with keywords, the first thing we're going to learn is like how to build an array in JSONLD, and then also like how you can have multiple values in that array with no real order, right? And I think that's okay for keywords because order isn't critically important. But if it is important, there's a technique later in the tutorial that will show you how to preserve that order. Okay. And so I've just sort of shortened the source just to the names of these keywords for right now. Schema.org for the keyword field specifies 3 different types that we can put in there. We can put text, we can put URLs, or this other object called define term. And we'll get to those last 2 later. But right now I just want to focus on the text. And so for the source snippet, I've just pulled out a couple of those keywords. All right. And so for a little just sort of shortened snippet, this isn't a comprehensive one, but one that's just shortened down for this specific field for you on the screen. I've cut out the @type data set and all the other fields just to make it easier for us to visually understand this field. And so what I've done with keywords is I've made a list with a square bracket for this term, and then put with comma separated values all the keywords into what JSONLD thinks is a list, or JSON for that matter. Okay, and so what happens here with this list, when a harvester comes through, it's going to grab all these keywords, and that's great, but we haven't specified an order. So maybe on the results page of some search engine, the order might be jumbled up. So nitrous oxide might not be listed first. It might be the CTD profiler. And so maybe that's okay for the keywords. And then in a later section, we'll show you how to preserve that. And that's specifically important for the authors and the contributors, sort of like that citation level metadata. And so we'll show you that technique. All right, so for our updated markup, we're just building on the record that we had before, and I've bolded out the keyword section. So we can cut and paste that and put that into our rich results. Here, I can just select all, get rid of that, paste it in, rerun our test. And okay, and everything looks good to go. It's detecting like the title now, it seems, or actually it probably did that before, but you can see all the fields here and how Google's interpreting in it. And you can see there's a keyword, every individual one that was comma separated has its own keywords value. So that's good. It means that Google's understood that that was a list and that there's multiple values for the keyword. Okay, any questions at this point in the room, online? No? Okay, all right. If I'm boring you, want me to move faster, just give me a shout here. All right, so we're gonna move on to one of those optional warning fields, the license. All right, and the lessons here are, so we've shown you how to like add like very simple properties like text fields, but I wanna show you how to add like an object as a value to a property. And so that's what we'll learn here with the license. We're gonna weigh out some like expressivity, which is like really cool and important in the sort of like linked data, which is that LD on JSONLD world, versus simplicity here in the record, and what we need to do and think about as data publishers or these sort of like content publishers. And then we're gonna reuse what we learned about arrays in this particular lesson. All right, so I've highlighted out of our sample metadata, the license section, and you can see right now that the license in our metadata has 2 fields. We've given it a name and the URL to the license, and that might be for a number of different reasons. For like display on web pages, you want to have Creative Commons Attribution 4.0, linked, and so we give a name and the URL here. And so I just want to demonstrate to you the 3 different ways in which you can use the license field in schema.org, and how our guidelines show you what's good, what might be better, but maybe questionable, but obviously what's a best practice as we're concerned. So, all right, adding in just sort of like a condensed snippet, we can just take that URL and put it right in as the value of license, and that will be good to go. So for example, if I just take this property here, copy that, bring it over to rich results, and just paste it right in. Or I guess I can do it at the end, that'd probably be the best. So I'm gonna add a comma. Coding on the fly, it always goes wrong, right? I'll paste that right in, run the test, keep my fingers crossed. All right. We're gonna look at what the record says. You can see that the warnings went from 2 to 1 now, and we can see that Google's picked up the license field, okay? And it understands it's a URL, I can click it, which means that Google can then go to that URL and harvest the content there, and probably decipher the fact that it's Creative Commons Attribution 4.0. All right, and so one of the techniques we can use, and I put that it might be better with a question mark because we're not really providing a ton of more value to Google or to the harvesters, but you can specify that instead of a string or a URL, I can specify an object, okay? And so this goes back to the question about why @types. So in this object for license, I'm saying the type of this object is a creative work, all right? And if you go to the definition of this field on schema.org, it specifies that I can either use URLs or creative works as the accepted values for license. So I'm sort of forced to say that this object license is a type creative work. And now I can specify my name and URL. And this is totally valid, it'll totally work, and that's great. But as part of the cluster work, one of the things that we came to realize is that not all licenses have URLs. And so just specifying the name of the license in the license field isn't going to work for schema.org. And so we needed to find a way to provide the community with URLs for all the licenses that might be possible. And thankfully, there's a resource online called SPDX that's already done this for the community. And so we can simply reuse those URLs at the SPDX for the license field. And so for example, and I think I've got a list here, if you go to this link here, you can see a list of all the licenses and the URLs for them. And so what I've done for us already is just say, hey, the SPDX URL for the CC BY 4.0 is this particular URL, and I can use that, all right? And so we understand, like, okay, not every repo is gonna go out and find the SPDX URL, and that's totally fine. You can leave the Creative Commons URL in as the license field, and that's great. But if you want to do it, you can add both. And this is just reusing that JSON array technique where I put square brackets and I can put my SPDX license URL and my Creative Commons, if you will. And both of those are valid. So let me, actually it's in the record down here. So I think I can just take this and paste that into Google. Oh, this is gonna be fun. Trying to grab that whole thing. Copy. Let me update my record. And while this is doing, do we have any questions in the room or online? Okay. Are we moving at an okay pace? Are we going too slow? All right. So again, we still have just one warning and one license. So, or excuse me, two licenses. Yep, that's right. We pasted in an array of the two licenses. So, all right. So let's keep moving. So off to identifier. So in our sample data set record, we had that line that specified the DOI. And what I want to show you is, again, just sort of creating an object property like we did for the license creative work. And so let's see here. All right, so the identifier property at schema.org accepts 3 different values. You can give it text, you can give it a URL to your identifier, or the sort of complex object called a property value, and we'll show that in a later section of the guidelines. But for right now, just text is great. So I can say identifier, and I can see DOI colon and the DOI value itself. Now notice that what we've done here is I've tacked on DOI colon to the value. Does that make sense? Is everyone seeing that? That I've put that inside the identifier. And the reason is if I just leave DOI colon out, the harvester just gets the number, the DOI value, the 10.26, and it has maybe no idea. So I'm trying to provide context to the downstream harvesters as to what this identifier is. And that's fine, that'll totally validate. And it's on the harvester to understand what I mean there, but there's a better way to do it, and that's to provide the full DOI URL. So that could be the DX URL, any of those, the HTTP version, doesn't matter, but a URL sort of provides the harvesters a better sense of what that identifier is. And we'll get to the best version, the property value, in the section downstream. So our record, we have an identifier, we have a URL to the DOI, okay? And I want to introduce this concept called same as at schema.org, okay? And same as for a data set, as all of you know, the data sets can live at various different places on the web. It could be described at data site because we've gotten a DOI. It could be at a different repository, a project page for the science team. And so same as tells the harvesters, hey, look, the data set at my repository, at my web page is the same thing as at data site or at data one. And so it just provides context to the harvesters. And I just took a screenshot here of the Google dataset search to really drive this point home. So I've searched for the dataset that we're building right now, and it's giving me two links. I can view it at bicodemo.org, the publisher, or I can view it at data one. And that's all because I specified the same as value. And so you don't have to know all the places where your data set are, but if you do know, and specifically if you're minting DOIs, this is a really great practice to say, hey, even though my identifier has the URL to the DOI, I can specify same as another place to find it. And so for this particular record at Google Dataset Search, the bicodemo specified the URL at data one as a way to say, hey, these are the same record, and that really helps the downstream searchers understand the context there. So moving on, we will just, I think sometimes there's like a copy link somewhere, but I'm not seeing it. That's all right, I'll just grab the highlighted stuff. Oops. I don't know if that worked. Any questions while I'm fumbling through Windows?
Yeah, Adam, in your example, the URLs were the same for identifier and same as, but the URL can actually be different, right?
Yes, yeah, they can be different.
Okay.
Yep. And that same as you can build out as an array. So if you know, oh, my page is at this repository and that repository, you can add all the URLs into that same as. Does that make sense? Okay, great. So just update our test. Okay. Great, and there's the identifier and the same as link for Google. Okay, so let's move on to specifying the publisher. So really here, I just want to drive home like how to create objects as values. And so we did something similar in the license for the sort of like better version of the license. So schema.org says the publisher can be an organization, so that @type organization or an @type person. And so if you go to our metadata record, I've specified an organization, even though it doesn't specify it here. But you as the metadata holder and the creator of schema.org records can make that distinction as you need. So I've added a publisher, and to specify an object as a value, use the curly brackets. And inside those curly brackets, you're then able to express new properties. And so you can build out this like really rich layer of objects upon objects, or objects within objects rather. And so I'm simply saying that the publisher is an organization. I am saying that the legal name is the name of the repository and the URL of that repository for right now. All right, and so I'll just add this to our schema.org. Any questions there on publisher? I know I'm sort of moving fast, but I want to get to the more complicated stuff where there might be more questions. Anything online? Run this test. Oops, did I mess something up? sure. Did I run the test? Okay. See what we got. Okay. So Google's saying, okay, I see a publisher, and then your publisher has these three properties. The type is organization, which is great, the legal name, and the URL. Okay, and we'll come back to this when we talk about specifying the difference between publisher and provider of the data set. So let's move on to the authors. All right, so here's where we're going to revisit that array and preserving the item order. And so from our source, you can see that there were 2 authors listed, and I'm omitting the ORCIDs for right now, just want to deal with their names to drive this point home on preserving item order. So we've got 2 authors and a contributor. Schema.org gives us 2 properties to deal with these, the creator property and the contributor property, and both of them can have either organizations as the values or persons, okay? And so I think we all remember how to build a list, an array, but when you want to build an ordered list, for creator, I mean, typically we would have just put in a square bracket there and listed the names. Instead, what we do is we build an object, so that uses curly brackets, and then a single property called @list. And this is a special property in JSONLD that says the contents of this array are ordered and they need to be preserved that way. And so when a harvester comes through and sees @list, it's going to say, okay, the order in which it's listed is important. And so Alison Santoro will always be the first author and Sarah LePerrier will be the second author. So this @list is really critical for your creators and contributors. So likewise, I'll do the same, even though Makoto is the only contributor, I'll still use the @list because maybe downstream in another version, there'll be more contributors, who knows, but it's just the best practice. Okay, and so I can add this to our markup on Google. Any questions here on preserving item list order? Okay. Paste that in, run the test. Yes. Yes, so I want to get to ORCIDs in a later section that demonstrates how to reuse a particular identifier pattern. But yeah, that's a great point. If you want to jump ahead in the tutorial, in the improving a dataset section, I show you how to use the ORCID, if you like, Marshall. Thanks for that question. That was great. Okay, so now you can see that there's no more warnings on the Google dataset search. We're getting the green check. There's no warnings or optional things. And so we can see that it's seeing creators, 2 creators and a contributor. They're both typed to people and their names. All right. Yes, Sarah, do you have a question?
An online question about, can you have a list of strings instead of objects?
Yes, you can have a list of strings, yep. So for example, if you wanted to take that list and just remove the @type person and the curly brackets. In fact, if you wanted to go back to the keywords lesson, I think it's section 3, and just put an @list in front of that, that'll totally work and that would preserve the order. Yep, great, thanks for that question. All right. So the next 2 sections, temporal coverage and spatial coverage, there's not really like a lesson here to be learned, but just sort of introducing how schema.org wants you to present this stuff. You can click to our temporal guidelines to understand more examples. We've got examples for a single date time. Here we're going to do a date range because I've got a start and end on the collection date. And then there's also a way to specify the open-ended date range. Now there's been questions in the community like, how do you specify a moving date range? And we haven't quite figured that out, but there's still work to be done in the cluster. And so for right now, we'll just show you how to do the temporal coverage for 2 date ranges, or excuse me, a date range, start and end date. All right, and so we just specify the temporal coverage field, and the mechanism that schema.org wants you to use is you put the start date, a /, and then the end date, okay? And that's how they want you to specify it. If it's an open-ended date range, you can do start date, /, ... and you can see that in our examples, or vice versa. If you have an end date, I don't know if you'd have an end date without a start date, but yeah, there you go. So any questions about temporal coverage? with just sort of your traditional ISO 8601 dates. I want to give nod at this point that Nick here up at the table has done some work on expressing deep time, and that's linked at the bottom of the tutorial. So there's ways to talk about millions of years, billions of years, and certain time periods by name. And so special thanks to Nick for doing all that hard work for us. Not to put you on the spot, buddy, but it's a worthy of recognition here. All right, so I'm going to add in our temporal coverage. Comma, space, run test. All right, we're still valid, and we can see, right, that Google picked it up. It didn't balk at the format there. So any questions before we move on to spatial coverage? Okay. All right, spatial coverage. Here is where we have an example of specifying a value that's an object that has other objects as its value. And so you can sort of see how you can build out these really rich trees. And so for the spatial information, I have a string for the value of the location. I've got a bounding box and a centroid point. So spatial coverage in schema.org lets you specify two main types. One is a geoshape, so that's for like lines and polygons and circles and things like that. But I can also just specify geocoordinates. So let's say, for instance, the only spatial metadata you have is a single coordinate. You'd use the geocoordinates pattern. Or if you have like a line, shape, box, or even a polygon, you'd use the geoshape pattern. So in this example, we'll show you how to do both of them, and we'll start with the geocoordinates. First off, we specify spatial coverage. We say that its value is an object, and so I do that with the curly brackets and an @type. The specification says every spatial coverage needs to be a place, so I say @type place, and it requires this geo property, and that geo property also has to be an object, as you saw above. So place has an object geoshape, place also can take an object of geocoordinates. So I'm going to say geo is another object, and its type is geocoordinates, and I can specify the latitude and longitude. Okay, any questions there? All right. So you guys you don't even need me up here. You can take this off, and I mean, please feel free to go. No, that's all good. All right. So for the more like shape type features, I give an example of a box. So since we have a northwest, east, and south bounds, we can do a box. So the specification at schema.org is totally wonky for spatial coverage. Don't know why they do this. We're trying to talk to them about how to do this a little bit better. But for right now, they ask for the 4 points. So the first 2 points are the southwest corner and then the northeast corner of the box. So it asks for the points in this particular order. So that's what we're doing there. But you can also specify it as a polygon. Excuse me, as I spill coffee everywhere. And so a lot closer to what we're familiar with in the community is sort of like specifying that sort of southwest point and then building your box in order. So going up to northwest, northeast, southeast, and then finishing at southwest. So that's what we're doing here. We can see 5 points. So there's my southwest, my northwest, my northeast, my southeast, and then finishing to complete the box. You repeat the same first point, the southwest point. So that's how you do polygons in schema.org. All right. Any questions there? I know I sort of skimmed through that, and it's not really like a convention. Yeah, Leslie. Can we get Leslie the microphone?
That's a square polygon, isn't it?
It is. That's a square polygon, yes.
You know what my next question's going to be?
Yeah. Give it to me, Leslie.
Does it have to be a square, like realistically?
No, it doesn't. So
Not all bounding boxes, like that's a bounding box as opposed to a realistic polygon.
Right, correct. So the polygon can be any of these shapes. So I'm going to click into the schema.org Documentation, I'll click place, and then I'll go down, find the geo property, and we can go to geo shape. Yep, and then polygon, and it's described as an area enclosed by a point-to-point path. So it has to be an enclosed object. And so it's just gonna follow all the points that you specify in that list. So I apologize, I was describing a box because that's the shape that was given in the metadata example.
No, it's just so many systems are limited to a bounding box as opposed to a genuine polygon.
Yeah, so with this polygon property, you can describe a complex shape.
No, that's what I wanted.
Yep. But it's not great. It'd be awesome if we could specify like a well-known text value, and that's something that we're working on with Google at least. Well, that sounds very pretentious. We're not working with Google. We're working in the GitHub repo that Google looks at, if you will, for this. So we need your community support on that front. So that would be great. Okay. So one other thing that's interesting, there was a talk given by Christoph Janowitz out at UCSD a while back on Google's interpretation of metadata like this, where we just have latitudes and longitudes. And there was some tool that was looking at a data set for the moon, and it was plotting these points on the moon in southern Sudan. And that was because there was no spatial reference system provided in the metadata. And so just to sort of address that issue, we put in this information in the guidelines of how you might specify a spatial reference system by using this additional property. And I want to preface this by saying that Google hasn't, subscribed to this this pattern here, but here's one way to specify it to maybe your other metadata harvesters like Data One or Ocean Info Hub. But Beth had a question there. No, that's okay. The spatial reference system? Yeah, so the way it's been described to us, and we had Dan Brickley here at the last summer meeting who sort of manages this, is it seems like it's kind of cyclical. They sort of wait for adoption or people to sort of misuse schema.org or publish in a certain way. And then they'll sort of like react to that to say, hey, we really need to fix this up, and then they'll do it. And so I think the more people that we have using and specifying the spatial reference system or specifying it in a different way using an external vocabulary, that will sort of push Google to respond to it. Otherwise, they'll just sort of move on to other areas like hotel reservations or, describing stuff that other people are clamoring about. So the more that we speak up on their GitHub repository, the more that they'll respond to it. So great question. That was a really good point to get through. Okay, so building out our sort of comprehensive record, I can grab this section here for spatial coverage, copy, which results. And while I'm doing this, any other questions or concerns, thoughts, snores?
Online comments from Steve Richards saying, pay careful attention to the coordinate order. It's reverse of other conventions, which just reiterating. And then also that Google is driven by commercial considerations. We're not really on their radar. So just echoing that sentiment. And there was a question as well from Joan Damerau online.
Okay.
So as you mentioned, same as to link to other URLs with the same data set. Is there a way to express related identifiers with other specific relationships?
Yes, a little bit. So I'll show you coming up in the sort of improving the dataset record, like how to talk about ORCIDs and ARCs and DOIs and sort of express that a little bit more. And there's probably other vocabularies that you'd want to use to describe even more properties on those things. And that's sort of not in this tutorial, but I would totally love for you guys to comment on the GitHub with those specific questions so that we can add those into the tutorial. Thanks for that, Sarah. All right, so I've added the spatial coverage into our record, and let's see, just to confirm that it's all looking good. So we've got our temporal coverage, we've got our spatial coverage with the place, with just a single property on geo, and we can see our geo shape. It's got our polygon there of points. Thank you, Steve Richard, for mentioning that the coordinates are sort of backwards there by the specification of schema.org. So please check your coordinates. And a good way to do that is at the Google Dataset search. I don't know if I still have that tab up, but maybe someone can put a link into the Google Dataset search that has a map, or we can revisit that point at the end. And then lastly, we're seeing that Google's seeing that we specified an additional property, and the property ID for that was the spatial reference system, and then I gave the value for the spatial reference system we were using. Okay, the last section of the sort of like simple stuff. I just want to show you how to like describe the data files that might be attached to a data set. And so for brevity, I just sort of shortened the metadata here just to one of those specific files. Schema.org asks us to describe the files by using a property called distribution, and the distribution accepts objects of the type data download as the value. And just a couple of the fields on data download, you can check out, there's a ton of them, but the ones that we're going to focus on are like content size, content URL, which is probably the most important, and then encoding format. And when we get to the metadata record and the improving the data set, we'll talk about issues with encoding format and some techniques that have been derived in the cluster, thanks to Steve Richard again, on how to be more specific. So for an example there, like, okay, we all have very specific dialects of metadata. So like an example of that might be, ISO 19115 or those particular records. So the encoding format for that would be application XML, but just saying it's XML doesn't specify that it's following the ISO standard or the NOAA dialect of the ISO standard. And so there's a way to specify that, and we'll show you that in the next upcoming sections. Okay, so back to our single file. I'm going to build a distribution. I put it as a list, even though it can be an object, but I put it as a list because there's other files described in our metadata. So if you wanted to build that out, you'd want to make distribution a list, and then make the contents of that list objects of type data download. And just by copying the values, I put in the content URL, put in the encoding format, saying it's a TSV file, and then content size is number, and it doesn't really matter because it's a text field, honestly, but I'm specifying here that it's 15,077 bytes. And so that's just, I wanted to mention that because the schema.org specification around content size doesn't specify that it has to be byte size. It could be kilobytes, gigabytes, whatever. It's up to the user to specify, and it's up to the harvester, the search engines, and the metadata harvesters to look at fields like this and interpret and understand what the user is trying to mean there. So trying to be explicit as possible within a text field for content size. I see a little typo. That's what happens when you're doing this late at night. But let's take our distribution for a single file in a list and add that to our rich results. And we're just continuing on to build this huge record here. All right. Paste. Did that work? Nope. I didn't hit the right thing. Copy. Paste. Okay, there's my distribution. Run the test, and while that's running, any questions in the room about how to specify files or online? All right, we're getting to the juicy stuff. The filet mignon's coming, people. All right. So rich results, we're seeing the distribution, the data download, the URL, encoding format, and the content size in the rich results here. Sorry. Okay. So that's like just building a basic data set record. There's probably even more in there that you need for a basic record, but that just sort of gives you a little bit of a walkthrough of JSONLD and some of the tips and techniques there on how to use it, and then just sort of like a simple data set record in schema.org. And now we're going to move to some more advanced concepts. First off, does anyone need like a 5-minute break? Like, listen, my brain is like on high heat and I just need to, okay. All right, so if you go back to our source metadata, in the keyword section, a couple of the keywords had identifiers for it. So like this keyword came out of a controlled vocabulary, okay? And I want to demonstrate to you guys how to incorporate that information into your schema.org record. Because that information to the search engines and to the harvesters lets them know, oh, this data set's talking about another web page over here, which might have more information. And that thing might be talked about in other data sets, and then build out this sort of like web of links that, oh, this controlled vocabulary term is talked about across all these number of data sets, even though I'm just talking about my specific data set. Somehow for these search engines and metadata harvesters, we're now creating this web of links together as we publish out this information. Okay, so in our metadata record, I want to highlight what this information means. So I have a name of CTD profiler, and I'm specifying that there was an identifier with a name and a URI in its source. And so what this means for this particular data set is that the term CTD profiler was a phrase used within the project. So while they were talking, in the 2 years that they were doing the data collection, they called it the CTD profiler. And that was the phrase they used colloquially for a controlled vocabulary term called CTD with this URI. And the same thing for the gas chromatograph. So they said gas chromatograph, but the repository mapped it to this term in a controlled vocabulary called gas chromatographs. So just a little nuance there, but okay. And there's one also difference between these is that the identifier for the gas chromatographs has this other property called ID, and that's called lab02. In reality, there is an ID for the CTD as well, but I wanted to demonstrate a technique in this sort of keyword control vocabulary so that you could see a term without an ID or a key and a term with it, just so you could see the use of these schema.org properties. Sorry, Leslie? Okay, can you just highlight it somewhere, even in the Google Doc, and just let us know? All right. Okay, so earlier on in the tutorial, we showed you keywords as text. And in this particular lesson, I want to show you guys how to use URLs and then also these defined terms, okay? And so here was our list before, and all I've done is added in a URL for the CTD profiler and a URL for the gas chromatograph. And this is totally fine and acceptable, and it sort of builds out that web of links. But you might want to be more specific and specify certain properties of these terms in a controlled vocabulary, and that's where we'd use the defined term type. So for that, I'd take that URL and turn it into an object. And here we're also seeing an array of strings next to objects, and that's totally valid in JSONLD. You can have an array with mixed types, and there's a link down at the bottom that describes that in the specification if you want to geek out on that stuff. But for right now, I'm adding in an object into our array. I'm saying it's a type defined term. I'm giving it the name CTD. That's the term inside the controlled vocabulary. I'm giving the URL to that term in the vocabulary, and I'm specifying what vocabulary it's coming from in this indefined term set. So that was a little bit of a lot to digest. Any questions in the room or online? Is it making sense, sort of like where that information's coming from? Yeah, go ahead, Beth. Yeah.
Related to my last question, is this getting picked up and used in, or could it conceivably be used in search to, go, oh my gosh, I'm linking out to this information about the instrument and seeing that it matches some terms in the search that are not present, on the data set itself, but are described in the instrument. So if I did a search, let's say for a certain type of data with, a certain type of instrument or something, might I be able to get back good results?
Yeah, the possibility is there. So like Google always tells us we're not going to tell you how our algorithm works.
Right.
So we don't know if they're doing it. But the possibility and the potential is there. So that might be a better question for folks like Ocean Info Hub or Data One, who can say us like, hey, if you put in a defined term, we promised to like go out and, I don't know if that, so I hope Matt's not online, I'm speaking for them, but the possibility for them to go out and harvest these other links through these defined terms, through these URLs is there to incorporate the words that they find at those pages into the search so that, the example that struck home for me was, what was it? The natural disasters. So you might have data sets about volcanoes and someone searches for the term natural disasters. You want all your volcano data sets to show up there because your term volcano is linked to the term natural disaster. So yeah.
Yeah, I know NASA is really interested in, doing different approaches to search. And so I'm thinking about how I might be able to go back there and say, hey, we should really be looking at this. And I guess it would be great if that could happen.
Yeah. Specifically with the GCMD keywords, right? Because
Yeah.
you link to one keyword and it's sort of like in this hierarchical structure. And
I'm also thinking about like the CIOS database has information about the satellites and the instruments that are on there. And also, about the bandwidths and spectral waves that they're using to collect data. And that could be really interesting for really searches natural language searches that we currently can't support at all, really.
Right.
So.
Hey, Adam, I'll just jump in here and say too that the essential ocean variables are also working in that direction as well. So, I think there are some groups that are working in similar things, and it would be good if we were talking to each other about things like that.
great.
But I guess I'd jump in too and say in the end, the bottom line is when you set up your metadata for harvesting, you need to be thinking about who's going to be harvesting this, because in a lot of cases, you sort of have, who's going to be harvesting. We've been working with the EarthCube geocodes, and we know there are certain things that the geocodes harvester sees and other things it doesn't see, likewise with Google. And so some of these more sophisticated kind of things like mixing objects and strings and arrays and stuff will work with some harvesters, but not with others. And the critical thing, if you're going to go to the effort of doing that, you need to test and see, are your target harvesters actually using that information? And if not, do you want to ping them or do you want to simplify what you're doing?
All very good points and good to consider. Yep. Thanks for that, Steve and Doug. Appreciate it. Okay, so I'm just looking at the clock and I might skip over exercise 2 on using the @ID for right now. In brief, it's just a way to, let's cover it. I'm changing my mind here. Okay, so we've gotten 2 defined terms built out. And what's interesting, you'll notice, is that in both the terms, they're both specifying the same term set, okay? And there's this technique in JSONLD that if an object is gonna be repeated multiple times in a document, there's a nice, easy way to just sort of define it once and then reference it by this @ID for those multiple times. So in exercise 2, what I'm doing is in the first mention of the term, I'm specifying the @ID and saying, okay, and @IDs are always URLs in JSONLD, or URIs for that matter, depending on how geeky you want to get. So I'm specifying @ID for the first mention of the term set, okay? And then in the second term where it's reused, I don't need to specify its type, its name, its URL, all those other things. I can just say, hey, I've already specified what this thing is. Here's its identifier. And I just need to say @ID. Does that technique hit home? Is that making sense to everybody? Okay, we'll revisit this when we get to publisher provider. Okay, any questions? All right.
Sorry, I jump in again there. Sorry.
Go ahead, Steve.
The thing to bear in mind here is if your JSON is being interpreted as RDF, as JSONLD, that works great. But if you're dealing with a harvester that's interpreting your metadata as JSON, it's gonna not work. So that's, and again, another thing to bear in mind about who your target audience is and how you think people are going to be using your metadata.
Great, thanks for that, Steve. Any other questions? So I'm just updating the keyword section in our document. Okay, we're still valid, thankfully. Keeping my fingers crossed every time I hit run test. And we'll just go down to the keywords section, and you'll notice in there, we've got the new defined terms. So we're seeing CTD profiler, but we're also seeing CTD, and we're seeing the term set that it's coming from, and then we're also seeing the gas chromatographs. And notice the indefined term set is pre-populated with all the other fields that we had there, even though I just specified the add ID. And I just want to make sure I did that correctly. Yep, okay, so in defined term set for gas chromatographs, I just specify add ID, but Google's interpreting it as, oh, I know what that thing is. I can just inherit all the properties over again. So this saves you time and space and effort on the JSON-LD side. All right, let's move on to identifiers. Okay, so if you remember with the DOI, we had sort of like the good way of specifying it as just text. We had the better way of specifying the identifier as a URL. And then there's really like this best practice of sort of giving the search engines and the metadata harvesters everything we know about this. And that's because schema.org let us specify a property value, which has other properties that we can add onto the identifier, okay? And so work in the group was like, okay, how do we uniquely identify all these different identifier types? And thankfully, there's an organization out there that's already done this for us called the registry at identifiers.org. So if you go there, it lists out a ton of identifiers. So I think it's just page after page. And so we've sort of highlighted on our guidelines documents, the sort of most common ones. So like DOIs, ORCIDs, ARCs, PubMeds, but there's another ones. I think even IGSNs are in there for the folks that deal with samples. Okay, and so what we're doing, here's some others, PaleoDB, Protein Data Bank. There's a ton of them at the registry. So the technique here for a DOI is to put in an @ID, which we just saw in the last section, and I'm making that the URL. Remember, @IDs are always URLs, so I'm giving it the DOI URL, and this helps the search engine say, oh, if I see this thing anywhere else on the web, like say for instance on the data site page for this DOI, or the crossref page for that matter, it can make that sort of same as link. So it's another way of sort of making that technique without explicitly saying it. So I'm adding a property ID, and that property ID is the URL from registries.identifiers.org for the DOI. And so here are some of those other URLs at identifiers.org for some other identifier types. Okay, and then just for completeness, I put in the value as that sort of string representation of my identifier, and then the URL. And so this is just like a common pattern you'll see across any place that you can put an identifier in schema.org, and you can put identifiers on virtually anything. So like organizations, people, a whole host of things. And we'll use this pattern to include the ORCIDs on the authors and contributors, and also on organizations for the funding sources, which you'll see in a second. All right, so let me update my identifier code and rich results. And any questions while I'm cutting and pasting here? Where is my identifier? There it is. Online or in the room? Okay. So I'm going to run my test. Let's see what happens. All right, we're still valid. Okay. I don't think we need to click in and show it. Let's just keep moving. All right. So reusing that identifier pattern, we're going to add in the ORCIDs for our people. So if you remember, we created a list of just the people names, but we had the ORCIDs in our metadata records. Okay. And so we can reuse this identifier pattern right on the people to specify the ORCID URL as the ID. The property ID becomes the ORCID version of the registry identifiers.org, the URL for the ORCID, and the value itself. Does that make sense, how we sort of did that? Okay. And we just saw the identifier work in the Google Rich results, so I don't have to paste it. I just want to make sure that we hit some of these other important topics. There's also ways, so because we're describing people, and same for organizations, there's all these other properties that if you have the information, you can specify in your records. And so, for example, for a person, you can specify the family name, given name, additional names, affiliations, which could be the organization that they worked at the time that they did the work. There's all these other fields that you can add in there. And so this is just a quick example of how you might do that for a person, okay? And we'll paste this into Google Rich Results at the very end and deal with what we've got later. All right, so hitting on that sort of like, oh yes, there was a question here.
Do you have to put the property value in for a person, or can you just do the @ID?
You can just do the @ID if you've specified it somewhere else, or it's specified somewhere else on the web. The @ID might work. So say, for example, you have a web page dedicated to that person, and that person has a schema.org record with an @ID in it. You can just use the @ID and hopes that Google's hit both pages. That is a technically valid way to do it. But you could, yes. So if ORCID is publishing schema.org about their person, you could just say, hey, go look at the ORCID page. Here's the @ID. I'm pretty sure ORCID has schema.org, so just reuse that stuff. So yep, that would be one technique to try out, yep. So I don't think in the Google Rich Results, it's gonna go off and do that for you. You know, the Rich Results tool is just sort of like, hey, I'll spit back to you what I'm seeing from you, but it would be up to the search engines and the metadata harvesters to go and do that extra legwork of harvesting that page and pulling it in. Yeah. Does that make sense? Any other comments from the cluster there on that particular point? Okay. Yeah, sure. Yeah.
I don't know if you want to jump in, Steve, but Steve was saying another interpretation of @ID you'll see is that the @ID identifies the JSON object, not a thing in the world. Basically, @ID would identify that particular representation of an identifier, not the thing the identifier represents.
Okay. Thanks, Steve. All right, I'm gonna skip provider for right now just to make sure that we hit some of the other more important things like variables and funding, which are new, but please come back to the provider lesson if you can, and we can revisit it if you have time. I see another spelling error here. Okay, so what I wanna show with funding is how to specify the awards that funded a data set or the funding sources in schema.org. And so there's two properties that you can attach to a data set. There's funding if you only know the funding sources. Obviously, if you don't know any funding information, you can skip this. But if you just know the funding sources, you can use the funding, or excuse me, the funder property. Gosh, I apologize. If you know the awards, you use the funding property. If you just know the funders or the funding sources, you use the funder property. Thankfully, if you have the awards and you know the funding sources too, there's a funder property on the funding object. And so we'll show that. So from the metadata record that we were using, we do have information about the awards. We have the award name, a URL where you can find more information on that award, and we have a source and the name for Schmidt-Olson Institute. And for the second award, we have a DOI record for the Sloan Foundation, and we'll talk a little bit about where that DOI for the funding source came from and how you guys might be able to look up those DOIs to provide more context in your records as well. Okay, so I'm specifying funding because I know awards. For the @type, I'm using monetary grant because I know that money was exchanged. There's a little snippet in here about subtypes. So if you look at funding and you click, let's just do it. So I'm going to look at funding. Where did it go? Where are we? Okay, funding. Funding expects the type of object to always be grant, okay? But within these vocabularies, you can have sort of subclasses, and one of the subclasses of grant is monetary grant, and monetary grant has specific other properties. So all I wanted to demonstrate here is that, you know, you don't have to follow the schema.org guidelines explicitly, that there's subtypes, and as long as a type that you want to use is a subtype of what they expect, that's totally valid. And you can see here that monetary grant has other properties that grant doesn't, specifically the amount of the grant and the funder of that particular grant. So in this example, that's why I'm using the monetary grant as the type of the award. All these other concepts we've sort of gone over, so like how to specify name, URL, and organization. And if you remember in my example, Schmidt didn't have a funding identifier, so I can omit that. But Sloan Foundation did. And again, this identifier pattern is so critical to providing this information. We reuse that pattern again to specify the DOI for the Sloan Foundation, which links our award to the Sloan Foundation page and that sort of web of data that we talked about earlier. So if you're interested on where to find these DOIs, and we got a question here, just real quickly, you can go to this doi.crossref.org and sort of search for funders and their DOIs. And so, for example, Schmidt does have a DOI, and I found it there, and that's the DOI for Schmidt that could be added in. Yeah, go ahead. You had a question in the room.
So it looks like on that one example, you're using the award number as the title. Is there a way to include both the award number and the award title?
Yeah, that's a good question. There isn't a specific property for like award number, right? I think there's been talk in the group about the award number almost being like another identifier. And so you could specify, here, let's just see. Let's see, so I don't have an identifier on the monetary grant, but I could add in an identifier property right there. And if you remember, identifiers can be text, URL, or these things. So I could just use text if I know the award number. That might be one way to do it. Or if there's a URL to the award. Yeah, does that make sense? That's a really great example. I'll make sure to add that to the tutorial. That's a great question. Actually, Doug, do you mind just sort of taking a note there, or someone from the group on award number?
Yep, I'll write her down.
Okay, great. So here's our funding information, all filled in with the identifier, and we'll skip the rich results until we get to the end here. So we just got 15 minutes left. Variables, a huge thank you to Steve Richard Online for really spearheading this effort with variables. We're gonna reuse the property value that we've seen before, and just for brevity's sake, I've just whittled the parameters of the variables in our example metadata to just a few. So please go back and take a look at this. There's a lot of different variation here. So variables measured in schema.org can be one of two things, either just straight up text, like if you know the variable names, or you can reuse that sort of property value pattern that we've used in the past. Both work. So if I was just to take the text values of my properties, I could put them in an array like we saw before with the keywords, and that's totally valid and that works, and that provides more context to your searchers. For folks who are looking for give me data sets with temperature, this would be one way to do that. But with that, the temperature keyword has to be the same as what they're searching. So what's even better than just using straight up text is this property value, because we can provide more words, more properties to describe what that is. And so for an example, with our cast, we can say, hey, the description is the CTD cast number. That's what we mean by cast, which provides more context to the downstream user as to what that variable contents are gonna include. So for another example of using the property value for variables, I can specify the name description on a property value type and add that property ID, which would be sort of as we've seen in the past, that's where we put the URLs out to these external vocabularies like registries, identifiers.org. And for the ISO date time variable in this metadata record we have here, we did have a link to an external vocabulary, and so I can specify that as the property ID. And if you go to the guidelines, there's a ton more on variables, so please check that out if you've got other questions on how to best use that. And Steve Richards on the call is another great resource. You can tag him in GitHub with any questions, or the whole group for that matter, not to put you on the line, Steve. But he's definitely the one that did a ton of work here in this space on variables. So just real quick on units, variable measured, if you're using a property value, the property value lets you express a unit text and a unit code, which is really great. And so for our temperature value in the metadata, we had both of them. So we can specify, hey, the unit text is Celsius, and I can specify the code as a URL to an external vocabulary that specifies what Celsius means. So You can add units, whether you have a controlled vocabulary or not. You can use the controlled vocabulary term in unit code, or if you just have a straight textual description of your units, you can use the unit text property. All right. And what's our last, or second to last section, metadata records. Okay, so very similar to the download, the data download, the data files there. We're going to reuse that same class, data download, but schema.org doesn't have a way to specify in that distributions list, like, hey, these are data files and these are metadata records. And so the schema.org group came up with some guidelines on like how to express that something's metadata records. And I want to highlight too that sort of issue that we had with encoding format. And so here's just like a quick textual description, or excuse me, a conceptual model of what this might look like for metadata records, is that you're going to have your dataset object using a property called subject of, pointing to this metadata record as a data download. And that data download record is going to have a property that links back to the dataset using this about property. Okay, and there's some text describing how and why, and there's more information in the guidelines about why that is. So let's just walk through this subject of and about. So from our dataset record, we're going to add in a subject of property and specify its type as a data download. Here's the content URL. It's totally funky, so I need to fix that. Yes, but it should be that darchive link to the NOAA ISO metadata. And then interestingly here, the encoding format, we talked about this earlier, how it's XML, and that's really helpful for the search engines to understand that it's XML, but to the community, they might want to know that it's this sort of ISO NOAA dialect, or ISO 19115 NOAA dialect. And so we're able to specify that as well in encoding format. And so any of those properties in schema.org where you say, oh, it only accepts text, or it only accepts this type of particular object, you can always turn those into arrays of those types. So here, and even though encoding format is typed as text, I can give an array of text values, or an array of text and URLs for that matter. So I just wanted to highlight that point. Okay, and then the about record. So I'm at my metadata record and I want to link back to my data set to say, hey, I'm a data download of this data set, and I'm metadata, and I'm ISO metadata from NOAA. What I did here in the dataset record is I specified an @ID for the dataset itself. And this is just a quick and easy way for me to use that about to link back to my dataset. So in that subject of, I just make a bidirectional link that says about is, hey, I'm talking about the thing that described me. Okay, does that sort of bidirectional way of specifying things that link to each other inside the same document? So, and then one last thing on metadata records. So for your search engines and harvesters, sometimes you don't need them to crawl your pages, you know, every single page, every single night. So one way to specify things that are changing, and I can't speak for Google as to how they do this, but certainly other metadata harvesters can use this technique, is to specify the date modified. So if your metadata hasn't changed in like, you know, a year, let's say, it doesn't, the metadata harvesters don't need to come down and like download the metadata again or anything like that. They can just use that date modified property as one way to specify that the content hasn't changed. Obviously, like content size might be another way to do that, but just wanted to highlight the utility of that date modified field might just be to specify to one of your harvesters of a change that's happened. Okay, and so this is the metadata record again that we're populating. And then I just want to give you an example. So I had to rush through this last section, but I wanted to show you how to incorporate external vocabularies, because this is really critical. Like, we're just right now in our context talking about schema.org, and certainly this community is so adept at using other vocabularies in the community. And so I wanted to make sure that we at least included an example of how to do that in your JSONLD, just in case you are. And so for one of those is specifying checksums for the data files, if you will. And so there's no way in schema.org vocabulary to say, hey, my checksum is using this algorithm and this is the value. And so we can use the SPDX vocabulary. And if you remember SPDX from the license list, They also specify a vocabulary for describing checksums and their algorithms. And so what we need to do first is modify the context. So if you remember, the context says, hey, all the properties that you see in this document are specific to schema.org. Well, I want to add in another context so that I can use this external vocabulary at SPDX. So what I do is I make the context an array, because I'm going to say there's going to be multiple vocabularies used. Okay. I leave schema.org in there, and with it just sort of as a standalone, it's going to be sort of like the base or the default, if you will, for all the properties. And now I'm going to add in an object of a keyed object. So the object's going to have one property, and it's going to be the prefix and the URL to the vocabulary. So for those of you who are familiar with linked data, this is a very common technique of like prefix and vocabulary, and then you sort of use the prefix in front of any of the properties that you want to specify. And so I'm going to show you that right here. So here's use of that prefix. So I'm saying SPDX : checksum, and all that really means is go to this URL and tack on the word checksum with a capital C, or go to this URL and tack on checksum value or algorithm or checksum algorithm. And so I can use that sort of same technique right in my JSONLD document to specify that a particular property is specific to a different context. Okay, so I can say that this data download has a checksum at SPDX, and that lets the harvester know, oh, checksum is in this SPDX vocabulary. And now I can say the at type is SPDX checksum, because if I just left it checksum without the SPDX : it would think it's in the schema.org vocabulary, and that's not true. So we want to make sure that we always use the external vocabulary prefix that we defined in our context. So I can say it has a checksum, here's its value, and then I can use the algorithm. And thankfully, SPDX has given us URLs for all these various algorithms, so we don't have to explicitly define it. We can just use one of these URLs. And so here's my SPDX block. So for the checksum algorithm, again, we're using that at ID concept, which says, hey, this thing is defined elsewhere on the web, and here it is. And so I'm reusing the checksum algorithm _MD5, which in the RDF linked data world just means that it's a named instance. That vocabulary defined this thing specifically, and we can reuse that thing specifically here with an at ID. So I've thrown a lot at you. We only have a few minutes left. I want to open the floor to questions, comments, thoughts, anything that we can do as a cluster to follow up from today. Mike.
Yeah, you've been real lucky with your live demo not having any errors. Can you show us what an error looks like? And
Sure. Yeah, I can. Oh, it's easy to mess up a record. All right, so I'm going to take out a comma in front of name and run the test. Okay, so I'm getting one invalid item, and it's mostly due to the structure of the document, not necessarily the contents. So I can click here and it says, oh, I'm missing a comma or a curly bracket somewhere. It doesn't know where. So what we could do in that case, there's another tool that we can use to do that, and that's called the JSONLD.org. Doug, correct me if I'm wrong. I think it's Playground. Or any JSON linter would do it.
Right, JSON linter would probably be the better one.
Is it JSONlinter.org?
Yeah, hopefully.
Okay, I'll just search Google for it because
There you go,
Google's my
just take
friend.
that guy.
JSON lint. So I can say Google hated my JSON, validate it. Okay, it found it on line 4. I'm missing, something between name and description.
And this is actually one of the more powerful aspects of JSONLD is that it is actually valid JSON. So any of the tools that you may have inside Vim or VS Code or that you normally use for JSON are completely valid for JSONLD.
So let me just show you adding in like that. Let's say instead of doing the SPDX checksum, I just did checksum, right? Which doesn't exist in the schema.org vocabulary. Let's just see what happens in the tool. I added the comma back in. Thanks for that. Oh, I didn't. Did I? Oh, you guys are on top of me. You guys are the best. All right. Valid. Oh, interesting. So it didn't detect that checksum is, I'm curious if it's in the list.
Try it in the validator at
It is in the
schema.org.
list. That's interesting.
So try it at the validator at schema.org, because this may just be looking at the JSON-LD structure a little bit more than it is actually proper,
Oh, okay.
schema.org implementation.
So schema.org has a validator too,
Yeah, I think it's validator.schema.org.
not validator.
Yeah, validator.schema.org.
Yeah.
At
At the
the
front of it, yeah.
subdomain. Okay.
Yeah.
Thanks, you guys. Oh,
And this is one thing is that, like, so example, the validator will check more so your
okay.
utilization of JSON-LD, whereas something like JSON-LD Playground is going to look more at just the structure of the JSON-LD.
Okay, great. Are you guys catching this? So it's a validator.schema.org, and we'll make sure that we add that to the tutorial. Let me just make this a little bit bigger. So you can see that it's got a red check next to checksum because it's saying, hey, that's not in the vocabulary. And you can see in the error column, it's saying the property checksum is not recognized by the schema, e.g. schema.org, for an object of type dataset. So interesting point. Thanks for that question, Mike. That was really helpful on how to validate some of this stuff. We're 1 minute over. I just want to offer up to you guys online or in the room any other questions or comments. If not, please hit us up anytime, schema.org cluster. My name's Adam Shepard. Thank you so much for spending this time with me. We hope to talk to you soon, and please hit us up as a resource as you might want to use this. Thank you so much.
Right.
Enjoy lunch.
Right. Great presentation. Thanks, Adam.
Great job, Adam.
Thanks, you guys. Thanks online, folks.